The second part is the scatter plots and the regression lines. What is the regression line or the scatter plots? As you can see, scatter plot is represented the data by using points. You can't connect between them. Why? Because some of the data cannot be represented by increasing rate or decreasing rate. For example, the temperature. Temperature today is 30, for example. Tomorrow, I can say that's going to be 31 or 32. And if it's tomorrow 31, after tomorrow, it's not necessary to be 32. So the temperature is not increasing every day by 1 degree or decreasing every day by 1 degree Celsius. So sometimes the representing of the data represented by some values, some encrypted value. For example, if today is Sunday, tomorrow Monday, Tuesday, Wednesday. Tomorrow I'm going to work out for 1 hour. Tomorrow 2 hours. After tomorrow 0. Wednesday 3 hours. Thursday 50 minutes or 30 minutes. So there is a change between the values every day. So in this case, I'm using the scatter plots. And the scatter plots, as you can see, it's representing data by using dots. It could be one of the 3 graphs. It could be a positive associations if the whole points is moving up, increasing. It could be negative if all the values going down. It could be no regressions, no relation between the values if it's all in the graph positive and negative. You can see if it's increasing or decreasing. The important part about the scatter plot is the line of the best fit. This line is called line of best fit. What does it mean? The line that passes through the most of the points passing through them, or even intersect 1 or 2 of them. But by using this line, I can find appreciate average or appreciate slope for the points. As we can see that the line of the best fit here is increasing, but the line of the best fit here is decreasing. The slope here is increasing, but the slope here is decreasing. We can see some values above the lines. We can see some values below the line. Let's understand it. For this line, this is the actual value, but it predicted by the line smaller than the value. Again, this point is the actual value of the data, but it predicted by the line higher than its predictions. And this is something that we are going to understand while we are solving. Let's go to the first example. The scatter plot above show the weight in ounces of fruits in a certain tree from days 55 to the day of 85. According to the line of the best fit. So underline this word. You are not working with the points. You are working with the line of the best fit. Don't take the points away from the line of the best fit. Which of the following is closest approximation to the number of day after flowing the fruit's weight 5.75? So here is the weight. I go to the point 5.75, which is exactly the midpoint between 5.5 and 6. I draw a line. I don't look at these points. Why? Because it says line of the best fit. Draw a perpendicular, as we can see that the value is between 75 and 80. And the only value lies between 75 and 80 is 77. So the right answer is 77. Second example, in 1990, the park ranger at Yellowstone National Park implemented a program aimed to increasing the downing populations in Montana. Results of the studies of the population in the park are showing in the scatter plot below. Based on the line of the best fit. Again, I'm not looking for the values. I'm looking for the line of the best fit. The scatter plot above, which of the following is closest to the average annual increase? So I'm looking for the slope. Average from a line is a slope between 95 and 2000. Let's go to the point at 95. So we can see that 1995 is with 20, and with the point 2000 and 2000 exactly at 140. So slope is y2 minus y1. 140 minus 20 divided x2 minus x1, which is 2000 minus 1995. So it's 120 minus 20, which is 140 minus 20 is 120, divided by 5, and 120 divided by 5 is 24. So the average annually is approximately 24. According to the data in the scatter plot, which of the following best represent the percent increase between the median of the results of the studies? Notice that he is asking for the median. In 1995 and 1996. In 1995, I have three values. The median is 20. And in 1996, I have three values. The median is 60. So from 20 to 60, it increased by 40. So 40 over the initial value, multiply 100 to change it into percent, is 200%. So the increasing in the median value is 200%. Another example, the scatter plot above shows the relation between the gas mileage in miles per gallon and the weight in tons for 10 cars selected randomly. The line of the best fit models the gas mileage based on the weight of the car. What is the weight in ton of the car for which the actual gas mile was closest to the predicted value? Predicted value, it means the line of the best fit. Actual value, it means the dot itself. Where is the closest point? The closest point is the point on the line. So the point on the line, its weight was 2.5. So I'm looking for the point that matches the straight line itself. The scatter plot shows the mean daily of high temperature in degrees and the elevation above for 9 points or 9 different points on a mountain. How many of the 9 elevations have mean daily high temperature that less than the mean daily high predicted? It means the line of the best fit. So I want the point that below the line of the best fit, because this value is predicted less than the mean daily high predicted by the line. The actual value predicted by the line greater than this one. So I have 4 values.